problem number 8 is very similar to problem number 7. Right? F of x is the tangent of 2x. We want to take the derivative, find it when x is equal to pi over 6. So f prime of x, again, we're looking at the chain rule. Derive the outer function. Tangent's derivative is secant squared. Keep the inner function, which is 2x, and then multiply by the derivative of the inner function. And the derivative of 2x is 2. So we're looking for f prime of x to be 2 times the secant of 2x squared, which means f prime of pi over 6 will be twice the secant of 2 times pi over 6 squared. So 2 times pi over 6 is pi over 3, so we have 2 times the secant squared of pi over 3. Now, going to our trig chart, we know that the cosine of pi over 3 is equal to a half, and the secant, therefore, is the reciprocal of the cosine of pi over 3, so the secant of pi over 3 is 2. So this is equal to twice 2 squared. Since we have secant of pi over 3 being squared, now it's 2 squared. 2 squared is 4. 4 times 2 is 8. With number 9, we have a chain rule, but we also have a product rule. So when we do our product rule, we derive the first term, and the derivative of x minus 1 is 1. And we keep the second, x squared plus 2 cubed, plus, now we keep the first term, x minus 1, and we derive the second term. And this is a binomial cube, so we need to use the chain rule. So the 3 comes out front. The inner function will stay in there, but we move our numerator, our exponent down to 2, and now we derive the inner function, and the derivative of x squared plus 2 is 2x. So there's our derivative, but unfortunately it doesn't look like any of our options. We have to do some algebra here. We have to factor out a common term. Our separator is our plus sign. That keeps our terms apart. We have to see what they have in common. Well, this has an x plus 2 cubed. This has an x plus 2 squared. So that means we can factor out the smaller amount of those, which is x plus 2 squared. Okay. Unfortunately, all of our answers have x plus 2 squared in them, so that doesn't get us any further, but we do want to write our leftovers. So in our first term, which is right here, we had 3 x squared plus 2's. We divided out 2 of them, which means we have an x squared plus 2 left over. When we have our plus sign, over here we eliminated the x squared plus 2, but we do have 3 times 2x, or 6x, and then we have an x minus 1. Alright, so we're getting closer. We still have our x squared plus 2 all being squared, and then we have x squared plus 2, and if we distribute our 6x, then we're looking at 6x squared minus 6x. And this right here, x squared and 6x squared, is 7x squared. So 7x squared minus 6x plus 2, and we see that right here with option D. Okay, moving down to number 10. Let h be a differentiable function, and let f be the function defined by h of x squared minus 3. Which of the following is equal to f prime of 2? Okay, well, let's find f prime of x for starters. F prime of x, we have h of an inner function. So we derive the outer function. H derives to h prime. We keep the inner function, x squared minus 3. And then we multiply by the derivative of the inner function. And the derivative of x squared minus 3 is 2x. So this is our definition for f prime, evaluated at all values of x. We want it evaluated at 2. So f prime of 2 will be h prime of 2 squared minus 3 times 2 times 2. 2 squared minus 3 is 1. So this is h prime of 1 times 4. So we're looking at B. And finally on this page we have number 11. We have the graph of f. It's 2 line segments. G is 2x plus 1. H is f of g of x. We want to find h prime of 1. Well, let's get h prime of x for starters. Again, we're doing the chain rule. Derive the outer, keep the inner, times the derivative of the inner. So we're interested in h prime of 1. h prime of 1 will be f prime of g of 1 times g prime of 1. So g of 1. If we plug 1 into g, we have 2 times 1 plus 1, or 3. Kind of running out of room here, so let me sneak down. So now h prime of 1 is f prime of 3 times g prime of 1. So we need g prime, and we got to plug in 1. But g prime, that's real easy. That's just 2. Doesn't matter what value I've actually plugged in, g prime is always 2. So we're going to multiply by 2 here. Now we need f prime of 3. So f prime of 3, that is the slope of the line tangent to f at x equals 3. Well, here's the graph of f. We're interested in the slope at x equals 3. Here's x equals 3, right there. We want the slope of that line. Well, that line passes through these 2 points. So if we do a quick slope, we have y2 minus y1 over x2 minus x1. So we have negative 6 over 3, which is negative 2. This is f prime of 3. So f prime of 3 gets replaced by negative 2. So h prime of 1 is negative 2 times 2, which means it's negative 4. A is our answer.